Good evening, everyone. It is once again Ted the Speed Learner, and tonight I'm going to continue my review of Danica McKellar's book, Math Doesn't Suck. There's only about 2 or 3 more chapters to go through, and as soon as that's done, we're going to move into another Danica McKellar book. That's right, folks. This one is called Hot X, and we're going to get into this very soon. This is what I'm going to call my summer reading project. It might go past the summer, but yeah, we're going to go into this. Anyway, so what's tonight's topic when it comes to Math Doesn't Suck? Well, here it comes. In this chapter, I will have to take you to an ocean. I really hope you enjoy the taste of water, especially seawater. But before you can drink ocean water, you have to desalinate the water because the ocean water does contain salt and other impurities. But let's digress at this point. I presume Danica McKellar is a fan of the website Livestrong or WebMD. I'm not sure which one, but she must be a fan of at least one of them, if not both. They recommend that a person should drink at least half their weight in water every day. That's what they said. This could quickly become an expensive habit depending on where you live. Of course, this fact is not mentioned in her book. She doesn't talk about how expensive this water is going to be. Danica McKellar also recommends that everyone drinks water from a major manufacturer. Well, she must have money. I don't. If you're purchasing that much water from a major manufacturer, you might not be able to save up for your retirement. That could be very unfortunate. But I will agree with Danica McKellar on one thing. She is correct in saying that consuming large quantities of soda pop is not exactly great for your health. So take both of our advice and drink more water than soda pop. Trust me, you'll thank me later. Danica McKellar is also correct in stating that most manufactured water measures their water in units of liters. So if you want to know how many liters of water you need to drink, you will have to do the same. You have to do some conversion math. It appears that the main topic of this chapter is a thing called the unit multiplier. As I stated in an earlier part of my review of this book, if you plan to become a pharmacy technician, you will need to know about this topic. Trust me. And you'll find this out if I ever get my PTCB on a budget book published. You'll find out real quick. But before I begin, I would like to state that I researched the history of unit multipliers. Apparently, somebody, someday, a long time ago, somebody that we know nothing about, just suddenly devised this mathematical concept, because there's no history on it. If anyone figures out who developed this concept, let me know. So, how does this concept of a unit multiplier actually work? Well, I think I'm going to illustrate with this ink pen right here. Okay. You can measure an ink pen in inches, or in millimeters, or in centimeters, or in decimeters, whatever you want to measure it in. It does not matter the unit of measure. Okay? All that matters is that no matter how you measure this, that pen doesn't change size. Just because you use the metric system to measure this pen instead of using the standard British system of measure, doesn't matter. The pen doesn't change size. Okay? So, let's say this ink pen, hypothetically, was 6 inches long. And let's say it was like 30 centimeters long. I know that's not really true, but I'm just saying, hypothetically, let's say this pen was both 6 inches long and 30 centimeters long. Well, the 6 inches and the 30 centimeters in this hypothetical case would be the exact same measure. It's just 2 different units. The units may be different, but the pen didn't change size just because you started using a different measuring stick. Getting the idea? So, let's go on. So what you're going to be doing when you're using a unit multiplier is you're going to multiply 2 fractions. What do these fractions actually look like? Let's use Danica McKellar's example to illustrate the fractions. you could place pounds in the numerator of it or the denominator of the first fraction. But if you place pounds in the numerator of the first fraction, and I'll illustrate this because I'm just so nice. Let's suppose you have two fractions. Well, that worked well. Okay. If you have pounds in the top fraction, you have to have pounds in the bottom one too. Okay, you're going to be multiplying fractions. Well, that doesn't work very well. Okay, you're multiplying fractions. Okay. So, if you place pounds as the numerator of this fraction, you have to place pounds in the denominator of this fraction, because you're going to cancel them out. Okay. So, and this would also be true if you decided, you could do this too, if you put pounds in the denominator of this first fraction, you have to put pounds in the numerator of the other one. That's how that would work. Okay. So, depending on where you put the pounds in the fraction, the first fraction, if you put pounds in the numerator of the first fraction, you put pounds in the denominator of the second. If you put pounds in the denominator of the first, you have to put pounds in the numerator of the second. So, let's say we're going to develop a fraction now. Okay. If you have the equation like this, what you're going to do is you're going to cross this off like this, and you're going to cross that off like that. That eliminates the pounds. Alright. Now, if you'll recall from some of my earlier math videos, you can actually multiply a fraction by something that represents 1 and still obtain the original fraction. So let's say now I did some research, and if you have a liter of water, you actually have 2.20 pounds of water. Keep in mind that the water didn't change weight. There wasn't more added to the water or anything taken out, just because you decided to measure the water with pounds instead of liters. Same amount of water. So this basically is a 1 divided by 1. And this is why you can eliminate this and this. Well, not the... You can't eliminate the 2.20 but you can eliminate the words pounds. So then you'd have a fraction 20 over 2.20, divide the 20 by 2.20, and you have your answer that you're looking for. Alright. So basically what you're doing is you're multiplying 20 pounds times 1. That's what you're doing. This is actually a 1, so that's what you're doing. You're multiplying 20 pounds by 1. So this helps us get rid of the weight designation, and it doesn't change the water, which is important. And like I said, to solve this particular equation, we just divide the 20 by the 2.20 and we get our answer. Now, if you decide to use a unit multiplier to solve a math problem, make sure the numerator of the first fraction is the same in measuring units as the denominator of the second fraction. I know I've said this like a broken record, but you have to do this. Also remember that the numerator of the second fraction has the same number of units as the denominator of the second fraction. Okay? So, in other words, we had the same amount of water, whether it was represented in liters or in pounds. Water itself didn't change. Our units changed, but the water did not. I realize that the unit measurement of the numerator of the second fraction will be different than the unit measurement of the second fraction. Okay? I realize that. So, liters is definitely measured differently than pounds. But if there are 3 apples in the numerator of the fraction, there must also be 3 apples in the denominator of the fraction. So if you got 3 apples on top, you got 3 apples on the bottom. Same difference. Alright, Danica McKellar actually says, and correctly so, that all unit multipliers are the equivalent of 1. The next thing Danica McKellar does is list several common unit multipliers. But you will not find in her book any mnemonic techniques to help you remember all these unit multipliers. This could become very important if you decide to pursue a pharmacy technician career. In my book, PTCB on a Budget, I will extensively discuss unit multipliers. And I'll even show you how to remember them. Danica McKellar then quotes some television stars from 2 different cable networks. What this quote has to do with unit multipliers is beyond my intellectual capacity. Perhaps she could have quoted movie or television stars that had directly used unit multipliers. Who knows? Then Danica McKellar invites you to fly to another planet. Oh golly, we're going to climb into a rocket ship. We're going to go to a completely new planet in some new solar system. I can think of a few sci-fi shows about that. Since we are going to take such a long trip, I thought I'd help you pass the time by telling you some interesting facts. The word mascara comes from the name of a town in the country of Algeria. I encourage you to research both the country of Algeria and the town of Mascara. Apparently, the French years ago tried to conquer the country of Algeria, and they invaded the town of Mascara. At that time, people used the mascara product not only as a beauty product, but as a treatment for various eye diseases. Interessante. I could present you with some further mascara history, but it would overly extend this particular video. I think we've taken long enough as it is. So let's go ahead and shift our focus from mascara to lip gloss. So where did lip gloss come from? It actually came from the Max Factor Corporation. But why did they invent lip gloss? That's thanks to the motion picture industry and the invention of color motion pictures. If you want to research these topics further, feel free to do so. Danica McKellar continues her illustration and shows you how to barter on an alien world. It's a fun way to cause students to learn about unit multipliers. After presenting a few unit multiplier examples, Danica McKellar presents her students with a learning style quiz. Then she states that every student learns differently. In some ways, this may be true, but when it comes to simple mnemonic techniques, every student can learn the exact same way. And Harry Lorraine proved it. I know I harp on this guy all the time, but he's 100% correct. Okay. The first question in this quiz involves finding places without a GPS device. But this quiz can also indicate how much effort a friend will exert to assist you. Let's think about this for a second. If a person just recites some directions and hopes you will remember what that person told you, it can indicate that that particular person doesn't want to exert much effort to assist you. If they remove a piece of paper from their notebook and they draw you a crude map, it could indicate that they may be busy, but they value your friendship at the same time. If they personally escort you to your destination, it could indicate that they will bend over backwards to assist you. This is truly an ideal friend. Of course, I didn't find any of this mentioned in Danica McKellar's book. Your website preferences can indicate some key aspects of your personality and even indicate various methods you incorporate in learning a subject. Some people are better at listening to an audiobook than they are at reading a text. Other people have difficulties in visualizing things that people tell them. And some people are more active than other people. When they are extremely active, it can indicate that they will perform well in athletic events. Those who are more introverted may enjoy sitting quietly in libraries. This quiz is comprised of 12 questions that can reveal much about your personality. I will let you peruse through the rest of the quiz if you own this book. If you want to share with me your thoughts about this quiz, feel free to do so. How do I feel about this particular chapter? Well, I found some interesting things that Danica McKellar could have included in this book, but did not. Why she didn't, I don't know. You'll have to ask her. Otherwise, it's an interesting book. You should check it out. Alright, I will tell you more in a future video, so I'd like for you to stay tuned.